Okay, so question 50 here, part A. Show by counterexample that if a plus 1 equals b plus 1, then a equals b is false. Okay, so we're gonna just find a situation here where this doesn't work. Okay, where basically this could equal this, but a isn't equal b, if that makes sense. Okay, so because they're saying if this equals this, then a has to equal b always. Well, I'm going to find a situation where this does actually work, but a doesn't have to equal b. Okay, so we have to be careful how we go about this, and the key to it is realizing again, right, that if we choose a positive value for one and a negative for the other, okay, where this works, then obviously a won't equal b. So it's all about choosing one to be positive, one to be negative. So in this case here, let's just go for an example here. Let's set a, for instance, to be 3. Okay, so if a was equal to 3, think about what you get here. Okay, this would work out to be 4, wouldn't it, when you did the modulus of it, right? So I'm just setting a to equal 3 there. Now, I want these to be equal, right? I want these to be equal, but I don't want to set b to equal 3 as well, right? Okay, I don't want to set this to equal 3. I want to set it to be something different to show that this statement is actually false. A doesn't actually have to equal b. So again, I want them to be equal, so I want to get 4 out here. Okay, I want to get this to be 4, but what can I set b here so that this comes out to be 4, but b is not 3? Okay, it's not the same as a. Well, if I want this to be 4, it doesn't have to be 4 in here, doesn't it? This doesn't have to add up to 4. It could add up to -4 if you think about it. Yeah, because this is -4. When you do the mod of it, it'll come out as 4, won't it? So we just need to think, okay, what number could I put here? So this would add up to -4. Okay. Well, if I put -5 there, okay, when I add 1 to it, you get -4, wouldn't I? And then the mod of it would be 4. Okay, so these would be equal, but a would equal 3, b would equal -5. So you get a situation where one's positive, one's negative. This is true. A plus 1 equals b plus 1, but a is not equal to b. Okay, so we found a situation where this is true, but this doesn't have to be true. A doesn't have to be true. So the statement then is false. Okay, by showing where you have a case where this is equal to this, but a is not equal to b. Okay, when it comes to part B, we've got to be really careful, okay, with this solving inequality thing. We've got to be really careful here, okay, because there's a quadratic in here. Again, I would do this plus minus thing, right? But it's not as straightforward as the other ones we've seen. So if I do plus minus there, you've got plus option, or then the minus option. The plus option means you have x squared minus 16 is less than or equal to 0, and or then this then minus x squared plus 10, take the minus through, is less than or equal to 6. So here you got minus x squared minus 4, no, plus 4, sorry, if I take that 6 over, is less than or equal to 0. Now, in order to solve these, right, I'm going to have to draw the graph of them, okay? I need to draw the graph because it's a quadratic. It goes back to C1 work where you've got a quadratic and it's less than 0, so you need to draw it, okay? But to draw it, that one's easy enough to draw. This one here is a negative in front of the x squared, so we've got to change that. So change the sign there, change all the signs, divide by -1, but you've got to change the inequality as well, the direction of it. So if I draw this graph here, x squared minus 16, now if you think about it, x squared minus 16 is just a smiley graph, but it goes through minus 16 here, doesn't it? Okay. And then x squared minus 4, okay, again smiley graph, but it'll go through at -4. Now it says here where it's less than or equal to 0, so I'm interested here in this bit here, aren't I? Less than or equal to 0 here. But what is this bit here? Okay, what are these values here? Well, when it's equal to 0, if you think about it, x squared will equal 16, so that means x will equal 4 or -4. Okay, so that's what we got there. But we want it to be less than 0, so we'll have to have x then between 4 and -4. Okay, so that situation has to apply here between -4 and 4, and it's less than 0. Here then, greater than 0, so we need to be this side. Let's think about what these values are here. Well, when this is equal to 0, x squared will equal 4, which means you've got plus or 2 there or minus 2 there. So that means then x is going to be greater than or equal to 2, or x is going to be less than or equal to minus 2. Now you've got sets of results here. It says here x has got to be between minus 4 and 4, but then it's saying here x is going to be greater than 2, or x is going to be less than minus 2. Okay, and we've got to put these together so that it makes one set of solutions. If here it's between minus 4 and 4, okay, it's saying everything, but here it's saying, well, no, actually, it's got to be greater than 2, so we've got to be like above 2, okay, and we've got to be less than minus 2. Okay, so it's got to sort of be greater than 2 but less than 4, less than minus 2 but greater than minus 4. So we're going to have two sets of results. We're going to say, look, x is going to be between 4 and 2, or x is going to be between minus 2 and minus 4. Okay, so I hope that makes sense, but with the quadratic here, you've got to go through this approach. With the modulus, you've got to draw the graph to see the separate results.